Hello everyone, I am Shankha Subra Sanyal and I welcome you all on behalf of S-Cube's classes. Well, I'm really thankful to all of you for your overwhelming response. The amount of love that you have shown through your mails, through your feedbacks, I'm really grateful. I'm really privileged. Hello everyone. Today we are going to talk about Ohm's Law. What is Ohm's law? Let me first give you the statement of Ohm's law. Ohm's law states that the current flowing through a conductor is directly proportional to the potential difference applied across the two ends of the conductor, provided the physical conditions like temperature remains constant. Let me explain this through a diagram. Suppose I have a circuit. This is my circuit, and if there is a source of potential over here, now what I do, I connect this and close the switch. So if the circuit is closed, what would happen? The current will flow through this circuit. When the current flows through this circuit, I have a source of potential, say V. If the current that is flowing through this circuit, according to Ohm's law, the current that will be flowing will be directly proportional to the potential that is applied. That means if I increase the strength of the potential over here between the two terminals, then the strength of the current would also increase. Let's put it mathematically. What does it mean? Mathematically, we can say V proportional to I, because what is my statement? It says the current flowing through a conductor is directly proportional to the potential difference applied across the two ends of the conductor. Let this be A and B. Across the two ends of the conductor, provided the physical conditions like temperature remains constant. I repeat. So, in order to remove this sign of proportionality, what am I supposed to do? We know from mathematics that to remove the sign of proportionality, I need to bring in a constant. And this is my constant of proportionality. What is this? This one is a constant of proportionality. And what we call this? We call this as resistance. That means what we can actually say that V is equal to IR. Or we can simply say, since we have V is equal to IR, I can say VI is equal to V by R, or I may say R is equal to V by I. That means the resistance of a conductor is the ratio of the applied potential and that of the current flowing through the conductor. So Ohm's law happens to be a very, very important law in terms of current electricity. If we need to draw a graph between current and voltage, since they are directly proportional to one another, if I draw a graph between V and I, what we find? Let this be my potential and this be my current. Since with the increase in one of the factors, the other factors increases and vice versa, so it will be a straight line. So the graph for VI will be a straight line. What will this be? This will be a straight line. And we also need to know from here that suppose we know 2 points, this and this. If I call this as I1 and this as I2, at this particular point, let us measure what is the value of V. If I have V1 and over here I have V2, then the difference between, or the slope as we call it, the slope between these 2 points will give me the resistance. Slope is the indication of the resistance. What is it? It gives me the resistance. So how can we measure resistance? Resistance is nothing but it will be V2 minus V1 by I2 minus I1. 1. That's how you can get numericals related to this. If numerical comes over here, what we can do, if we suppose have 2 points A and B, then in that case from these 2 points we can calculate the difference in the potentials, we can calculate the difference in the current, and we'll be getting the slope which is equivalent to the resistance. So this brings us to the end of the lecture. Well, before I sign off, as I always do, I would request you, in case you have any queries, please do feel free to write to me at scubesclasses@gmail.com, or you can WhatsApp me on the numbers given on your screen. It would be a privilege on my part to be addressing your queries. Thank you so much.